Okay, I would like to present Jeff and Yvonne from our cohort 1, Astroblocks.
So this was our project. We were coming out, kicking around some ideas. We did actually 2 projects in that cohort. This was the second one. The first one was a play on confessions in the blockchain with coinfessions.me, whereby you could write, and your secret was secure in Satoshi, where you could put your ideas and your deepest, darkest secrets into the blockchain. This was an extension of that idea, but instead of a secret, here we were talking about the idea of astronomical discovery. And so the genesis of this really came from the idea that how does one put one's discovery of an astronomical event, I want to say astrological, so that's why it's so difficult for whatever reason, by an amateur astronomer. And the reason why you'd want to do this is, of course, you get naming privileges for this event. And I found it to be very challenging to put this kind of information into a current system. The workflows were very complex for an amateur. One system for asteroids, one system for variable stars, one name for all sorts of things. So it was a way to simplify the process. Oh, what's going on? That, I pressed it too many times. So what the goal of this project was to communicate in a timely fashion information to a community of practice, and then have that information communicated, verified. In essence, a form of peer review of time-sensitive data. And when I looked at it like this, it really looked like a blockchain encapsulation of a transaction chain, whereby you're passing information from various individuals or various agents throughout doing different types of work. And so initially, the idea behind Astroblocks, the mechanics of it will be explained by Yvonne.
So first we have Alice. She found an object, so she goes to the Astroblocks website and input the information of the object, so people can find the trajectory. So this information is hashed because we want to protect the identity of the observer. So when they're being verified by experts, the verifications is unbiased. And we will put this information via op return on the blockchain, so to prove that the observer actually did the observation. So this information is, this is a transaction to a multi-sig address. And in our examples, it would be a 2 or 3 multi-sig address. So we have a panel of 3 experts in this example. And what happened is we have 2 separate branches. So if 2 out of 3 sign off on the yes transaction, then this observations is proved to be valid. And if 2 of them sign off no, then it's invalid. And then the valid observation will be documented in our database and also on the blockchain where people can verify it.
It's a way to keep all this within the blockchain proper in a transparent fashion, so that one could see, Alice could return to the blockchain anytime in the future and determine, based upon the outcome of this multi-sig transaction, whether or not this discovery was verified or disverified, unverified. And that was basically the idea initially with this idea. And for the verification engine, we used this idea of block.io. They had a D-trust, distributed trust algorithm, which we liked very much. And with the idea that each one of these multi-sig separate sign-offs are known, if you will, they were the validators of this transaction. And we like the idea of keeping it within the blockchain because it's very transparent, very traceable, and you don't need to build any extra infrastructure around it.
And also the observer will know where in the process is their application. Like unlike right now, you have to email some organization and they're going to send it off to a professor, which you don't know if they get the email or might take them 2 months. But this you can know, you can see the transaction
You can see
chain.
the whole workflow process. Yes?
Are the multi-sigs time bound? Like during the review process, does each participant have a certain amount of time they have to do the review and sign, yes or no or whatever?
So, no, currently. So the idea was the check block time verify opcode hadn't been yet formalized. I think it was just formalized this week. So the idea is you could now create transactions whereby if Alice were to send in the transaction, it would bounce with a fee associated with it, with the idea being that it would incentivize the professors or individuals looking at it to actually do their job and say, yes, that is an observation that we verified. If they don't do it within that time, then they could get bounced back. She could get a refund, if you will, of her transaction. So, but as of yet, no. And it was something that actually we're going to see in a second, the site for real. And it was interesting with regard to Tim's talk today, because I was talking just yesterday to Yvonne about some ideas we've been kicking around. Well, this is great. The op return is a great first step just to get it done and fast. But the idea at the back of our heads were always, well, how do you do it in a permissioned or permissionless system like Eris or another tool, or just keep it within the blockchain. So we'll see that there are some trade-offs in all of these systems. Well, and again, we use Bitcore for most of the coding because it's a robust API and very useful library. And the reason why I'm going fast is we just want to go look at the website. It's because we're going to see that some changes have been made, some radical changes because of input with regard to the first time we showed it. This was, again, one of the ideas that we had in the back of our head was, where is this going? Like, we saw that there's a big need for people wanting to put their information or their story up on the blockchain. So this was one of the things in the back of our heads that we kept with. So for the potential for Astroblocks, well-suited, blockchains in general, well-suited for time-sensitive data. And this platform could be used as a tool to connect individuals together to verify and review that data in a cost-effective manner. And the idea, again, is a person looking at and verifying Alice's discovery could, at their leisure, come in and look at the data on their tablet or their computer and verify, yes, that's a valid discovery or that's not a valid discovery very quickly. So lowering the barrier to verification.
And then originally we thought this can be generalized to, people's inventions, or they have a new idea for a startup, and then they want to contact with experts to see if that's a good idea. So you can have like 2 or 3 voting on the idea whether they should go forward. So that's an example.
So one of the examples of this we're initially thinking about, and we said, let's go with the lower hanging fruit, was, well, you could have the idea for IP. If you have an idea and you don't want to spend the $20,000 to get a patent or the $5,000 to do it yourself and not do a great job, well, you could maybe vet your idea out to a number of different patent attorneys in which you could have a tweet almost of your idea, 2 diagrams, and then send that with a fixed amount, let's say X number of dollars, and then have the system send this out to all available attorneys that are signed up with the service, and when they have 5 minutes available, they could look at your idea and vote, yes, this is a good idea, no, it's a bad idea. And to incentivize somebody not just saying yes to everything, just do a shackle coin, something where you only pay the correct answer. So by you disincentivize somebody not doing the due diligence and reading through that little blurb and making a rational decision. Yes?
If you said this and I missed it, I apologize up front. Where do you actually keep the source document?
So the source document, that was a question initially just within an internally controlled database. Hence the idea of, do we go with something like Eris and have our own blockchain with all the data embedded, or do something like IPFS where the data is out there and just you're referencing the content, which I think is a better idea in some regard. So that the only thing you're seeing here is a hash that allows you the location of that data.
I see.
So, well, let's take a look at Astroblocks, the website.
The original one.
The original one, and then let's look at what happened while this idea was being kicked around for a bit, because, oh, you good? Right. All right, so, oh. There we go. So why don't you go through this?
So this is the original website. So when you come into the website, you'll enter your information. And of course, when it's sent to the experts, your personal information will be hashed, so they won't be able to see who sent it in. And then you pick the object, you enter the information, and then you submit them. And then you will go to this page. You'll see the data you're submitting. And then if you pay, for the Bitcoin payment, we'll set up a transaction.
Now, actually, on this one, I'll do a pause for a sec. So this is this is very much like proof of existence, with a couple of key design decisions that I think make it a little bit more, a little bit better. One, it actually sends you an email, so if you lose the next page, you can get it. So it's just taking these ideas and just refining them and making them more user-friendly and more apt for use. So after you make the payment,
And then, so say if you're on the expert panel, and this is what you'll see. You'll see a hash of the observer's identification, and then the information of the object. And then you'll have two, you can pick which one you're signing off on. And so this is sent to, three experts in the example. They will see this page. So if two sign off,
what are they seeing? They're seeing a hash.
So what they would see here, it's not shown here, when they were to, if they were to click on this, they could get to the internal database that Astroblocks controls and see all the information available, including the...
Here you will see the information of the object. So that's all they need to verify whether they are able to find this in the sky. So this is just an example, but then they won't see who's submitting it, but they will see the information of the object. So they only need this part.
So this is the useful information saying, yes, I made these observations, bright ascension and declaration of this part of the night sky on this, fast forward to whenever that date is. Yes, that is a valid object called asteroid. And then they could say, yes, I did observe this information myself. Sign off on the yes or sign off on the no.
Do they see who signed off?
No. So in this case, the system is building up the multi-sig transaction in the background. So once 2 out of the 3 have either agreed or disagreed, then that gets published, or rather spent out.
And you can set up the number of multi-sigs to almost anything you want.
Almost anything, yeah. So you could have this, of course. Now with the idea of the IP information, this is very binary. It's yes, no, not very much, not very data rich. So one of the ideas we were kicking around, a better idea, is you could have it whereby if you have, let's say, 10 people, you send your idea to 10 different attorneys. Every attorney says, hey, yes, no. You could get back in the op return of the final transaction the percentage of yeses and nos in the op return. So you could see later, after everything's said and done, 51% said it's a good idea. Now with that information, you can do something with it. You could say, hey, that's a terrible idea. I should not spend the $20,000 for an attorney. 51% say it's a good idea. That's not too good. So in a sense, it's very much like a highly specific predictions engine, whereby you have a very limited or a very capable set of individuals for that particular question answering a particular type of question. So in the general purpose uses, I don't think that will ultimately be very useful, because it would work if you had a much larger population of sampling from. So we just focus on just IP attorneys, astronomers, etc.
I have like the perfect use case for this. So I proposed, so in an accounting firm, there are a lot of companies that have very specific questions for which they don't want you to know who they are, and they want to get a view of the answer across a distributed group of people.
That are very specific.
But
types.
have a very specific set of skills.
Yes.
Love that movie. So, and so the idea was that we would create a site where people could put questions in, tax questions, and then it would go into like a bucket where people could answer it like, yes, that's the right answer, no, it's, I mean, you could frame those questions. I mean, this would be like the perfect platform for something, or what am I missing?
Where were you? Because everyone else had another idea. That was actually where we were going with this until we got all this feedback, and we pivoted a bit. But this, we could talk more about, because I really like that idea. Because my idea was, you know, I know a lot of my friends are doctors, and radiologists in particular, and
Right.
I never knew this, but even 10, 15 years ago, when you break your arm, there might not be a radiologist on site. You get an x-ray, that is then sent out to a network of radiologists. They check in when they have a couple minutes free, and they say, yeah, that's a broken arm, whatever. Once all that gets aggregated, and they say, well, 3 people said it's a broken arm, therefore a report's issued saying you have a broken arm. Same idea, but now you're also giving the end user the percentage of people saying, yes, that's a good answer or a bad answer.
Yeah, I like the percentage aspect because a lot of times definitive answers don't exist in those
Exactly.
questions, right?
Yeah.
Even though you think there's a number, and you know, but you give 10 tax lawyers a question, you're going to get 10 different answers.
Although I would hope in the radiologist case there aren't like
Okay, there is quite
cancer.
And I'm very sensitive to asking because you do get a range of answers, and I
Plus,
remember,
the other thing is what you could do, and as Chris would tell you, is we have different skill levels, right? So what you could say is you could say you want to position the question at a certain group within our firm because, you know, senior associates within our international tax function, you know, you could have 800 of them, right? And you only need 20 people to look at the question and hit yes or no. And then you, as the receiver of that information, don't know who it is. And you're not saying definitively if it's yes or no. What you're saying is the percentage of people that looked at the question said it was yes.
yes or no, yes, yeah.
It all depends on the question. Okay.
Oh, well, yeah,
Shit,
I mean, sure,
this
but
is great.
it's one of those things where, you know, exactly, you can get much better information to the end user.
Yeah,
It's
for
not, you know, not this binomial distribution, but rather a more nuanced understanding.
Right. It's pretty cool.
So sad, because everyone said, you know, after we gave this talk, everyone said, man, I'd love to buy a star. And we thought, if everyone says something, right,
Yeah.
well, then go with what everyone says. So,
So
What
traditionally,
would you call it? Tax blocks.
Yeah.
Astroblocks 2.0. Right?
The public domain, Jamie.
So-
That's right. Go daddy.
we ended up pivoting, but yes, we can talk more about that because we even had a title for it and a very neat logo for
All
that.
right, all right.
So,
So yeah, traditionally, because everyone say like, do you guys sell stars? Why don't you do that? And then originally we did not like the idea because it's frowned upon by astronomers because most of these sites currently that sell stars, they look like they have an updated site from the 90s. So they look like GeoCity sites. And they are all, they don't give back anything to the scientific community. So they're just making money, you know, off people.
show an example.
And this one is actually already a better one because they're actually, they do donate back to the scientific community, but they look like this, you know.
And you don't
And
really
then-
know if you've actually owned that star. What if
Yeah.
there's a possibility they double sold you the star?
That's people's general complaint. They say once they said they bought a star and then they said, but I don't know where to find it. I don't know what I bought. And then yeah, I don't know if it's unique. I
Don't
don't know
know.
if someone else owned it.
And so the blockchain seemed an ideal situation for this asset class, where you could put this asset, this star, and your ownership of it into the blockchain, and then know that you own it, and no one else owns that particular star.
Well, wait, you own it
So
in
this-
your own world, right? I mean,
Within the Astro.
within the Astro world.
Yes.
That's right.
So this is our competitors, so they have kind of not very good graphics. So this is all you get. You get a certificate that's printed. Oh, whoops. And I think I accidentally put the site. I guess we could go to our
Let's
site.
go to ours.
So,
So we pivoted with the input from others, with the idea of you can find your place in the cosmos within Astroblocks, whereby you can comment, look at a star, and say, hey, I don't know, I'd like a star. Or I'd like to find my friend. So some of the design decisions that we were taking up on this is that the user would log in through a social media site. That the act of buying a star, we think, is really a social phenomenon. That you're purchasing the star not for yourself per se, but perhaps for a loved one. And so it makes sense that you would want to buy a star and then claim it, and then perhaps even give it to your loved one.
so this is
well,
use
before-
cases.
So here are some of the use cases. Again, give the gift of science, so you'd be donating a portion of your of the proceeds back to science. It'd be, the blockchain is forever. Now this is where we were having a bunch of discussions. Right now it'd be an op return, just like Josh Cincinnati put his love for his girlfriend on the blockchain, and I did for Yvonne. If anything were to go wrong, you can't pull that out. And hence the idea of, this idea of using permission systems or another way to color coins. Actually, we were thinking of color coins until sidechains and the idea of an asset issuance transaction that you could then move a transaction out. And that's a much better technique, because with a color coin, it's very easy to do a one-to-one transaction. But I thought, well, if you own a star, maybe you want to give your kids portions of the star. Maybe you have 2 kids, you give them 50%. You can't do that with a color coin very easily. But with sidechain, perhaps you could.
When you said you couldn't easily take it out of op return, like what are you? I'm not sure I followed.
Once you put, so right now there are different ways to put information into the blockchain.
For sure.
The worst case is proof of burn, which, I've done that. I think a lot of us have done that, where it's a bad idea. And then, of course, with the Bitcoin client 0.9 came the op return, and the idea that you could put information in there in a prunable manner. It's basically a null return. You just throw in your information. But once you put that in there, you can't take it out, per se. It's just in the blockchain.
I mean, you can still see it, but what you're
You can
saying
still
is
see
you
it.
can't
Modify
edit.
it. You can't edit it.
Okay, all right. I wasn't sure what you meant.
Oh, sorry.
Okay,
Yeah.
I
So
got
with these other ideas, like color coins, like with asset issuance transactions within sidechain, there's the idea that you could then move it around and say, well, I like this other person, and move your star around. And then, lastly, it's telling the story of a loved one. Some of the ideas. Now, you'd have, again, proof within the blockchain that you actually own that asset. It makes sense. Blockchain is very well suited for these kinds of assets, property. People are doing this already with a number of different uses, factum, etc.
And then, people can have the peace of mind that it is unique, so only they, own this or and that.
I mean, unless a competitor comes up and sells that same star to somebody else, right?
They wouldn't have the Genesis block with our data set. So we would have all the...
But they create their own Genesis block.
Well, yes, but
What about an alien on another planet that already sold that to
Well, we
another
would
alien?
sue them into the ground and exert ourselves. But the answer is, hey, what else would we give them? We also give them a physical token detailing the star and the star local group that it's within. So they get a 3D printed physical representation of this asset.
So when a star turns into like a white dwarf and like all that, and then the gift that keeps on giving, you can then sell it again. Different
Exactly.
asset class.
Yeah.
Exactly.
And it collapses upon itself.
So let's say you did, now why would you do it? I like the idea that you'd have districts, because it is a social phenomenon. You and your friends find out, you go, hey, I want to visit my friend. Now, one of the people that actually told us, I'd like to buy a star, is not here, is Tim. And I thought, well, he wanted us to secure for him Alpha Centauri.
So
So
here
we
is
said
Alpha
fine.
Centauri.
So
So
you-
now I put a marker on it. So red means it's sold.
Okay, yeah, hold on. So if you come in, it's terrible, it's not here, but if you come in and say, hey, Tim's got Alpha Centauri, maybe you want to buy it, you now know who to talk to get it. You could then do trading of these objects within the system.
Or I could even buy
Like baseball.
Andreas Antonopoulos, Alpha Centauri B, just to annoy Tim and put him right next to him.
Exactly. And you, the purchaser, could come in and get a custom website explaining who you are. It explains also what the object is, Alpha Centauri, where it's located, information all about it.
So,
And you got your proof of occupancy.
and then
Within the
this
blockchain,
is
you
just
can
an
search
example with transaction you can see in the block explorer. But this is all very, very primitive right now because we just started working on this week. So
We'll go back to what about I want a star?
Are there any sales? Maybe I'll pick one up.
Well, that's the thing.
So
we're-
this, for example, here,
within the.
well,
I'm
when you
willing to
see
go
it,
into one of the worst corners of the universe. If there's a deal there, I'll do it.
so here actually this one is, you might be interested because it's a red giant, so it's not not habitable. And then, so if you see a green dot, so that would mean it's for sale. So if you hover over it, it would say vacant for sale. And then we haven't worked on this, but if you click into it, you'll be able, make your transaction, I imagine.
Yes.
So how do you confirm with other star purchasing databases that they haven't, someone hasn't purchased off of your database, a star that hasn't been purchased off of a different database?
So that's a great question. The question is, well, how do we know that somebody hasn't already bought
I just asked that
a
5 minutes
particular star?
Yeah.
Well, it's like, first off,
me up. I was like,
the data set that we're using.
Quite the same.
it is.
Well, also, I think there are actually multiple sites like this right now, but this is the first one that's using the blockchain, so you can actually prove your, ownership.
Only in the database, but not in the blockchain yet. So.
Right.
It's
Well, there's like those sites,
right.
you mentioned those sites from like the 90s where
Yes.
people bought stars. Like chances are somebody bought Alpha Centauri in
Yeah.
like 1998 or
Yeah,
something like
but this
that.
is, we
Wow.
start fresh from the
Or
blockchain.
we're just kind of throwing those out
We're
there.
just going to draw a line in the sand
Okay.
and move on.
So basically the star data, so they're all just JSON files, and then you can add as many objects in the future as you can. So this is like from the Hipparcos catalog, for example, and each star is just coordinates and the magnitude and the Hipparcos number, for example.
But your food truck idea from last week would work good with this multi-sig kind of going out there. Remember? We talked about-
It's not multi-sig. It's
Well, you
it's a
said to
different
do the
co-
voting on whether or not, right?
Well, there's an option.
no. There's an auction function
Oh.
that we actually we hashed out today. No pun intended.
Oh, did
But,
the breakfast food truck?
no, not a breakfast food truck. I mean, we can give you our pitch
Yeah.
on
We
that.
don't want to take thunder away.
But we don't want to. Yeah, exactly. We don't want to say the thunder. So, yeah.
So that's Astroblocks. It's something fun. It's again using, I think, this idea of blockchain technology to secure one's ownership or ability to move control over an object. In this case, an astronomical body.
And also, we were thinking, for the donation, we can have it in a code so that, like, for every transaction that comes in, according to which organization you select, it will automatically, times a multiplier and generate different outputs to these different Bitcoin addresses that fund these causes.
So you can see she's a physicist, so likes to do things very complicated. We got one fudge factor with another overlaid on a couple of probability distributions. So, and that's it. That's the idea.
Do you get options on the orbiting planets?
Well, actually, a friend of mine.